Oh, you guys can't see nothing. Okay, so we got most of this part done the other day. I'm going to pick up from the shear diagrams and work our way through the moments. And I'm going to show you the simpler way to do this. Also, it's a lot less confusing the way the book is trying to do it. And this is the way I learned it. This is the way I do it. So in making this bit here, hopefully it'll make sense to you. But ask questions along the way. Okay. So let's get some numbers in here. So we got it. This was a -25. So that's our shear. That's kips. We came up here. It was 27.5 kips. We were here, and this was 2.5. Okay. And then we went down to -22.5 kips. Okay. So what we're looking at is this here. And we had A, C, D, E, and B out there. Okay. Everybody hanging in there? All right. So if I do this, let's do it right there. Maybe not that big. So put the moment diagram right here. Okay. And it goes something like this. The easiest way to hopefully sort this out is as such. All right, so I got the moment at A is 0, okay? There's nothing there. There's no distances at all at A, okay? Everybody good with that bit? Cool. But at C, I'm going to be the moment at A plus the VA times the 1 foot, okay? And really what I'm looking at is this area right there, okay? So if I do this, remember that the moment is the area under the shear diagram. Life's a little quicker and easier for you. But the reality is, at this point at C, I'm going to have a moment of negative 25 kips times 1 foot. Okay? In order to have a moment, I got to have a force and a distance. Are we good there? Good. Okay, so you don't really need to write MA at this point because it's 0, but trust me, it's always a good idea to keep your bookkeeping straight. All right, so VA is negative 25 kips, and I'm going to multiply it times the 1 foot. That'll take me over to C, okay? And when I do that, I get a negative 25 kip feet, okay? Oh, let's see, we need a different color. Let's use purple. Oh, I was going to do it in green. Sorry. So right down here, negative 25 kip feet. And I'm going to draw the line in like so. Okay? Area under the curve. But mind you, every time I transition a distance over, I have a small portion of a moment adding up to that 25. So far, so good? Carter, you're the gauge of stress.
I'll do my best.
Okay. All right. So with that in there, the next one becomes D, the moment at D, is equal to the moment at C, plus the VA, or actually, what did I say? VC. That VC times the distance across that. Oh, that'd be another good thing to put in here, wouldn't it? 1 foot, 2 foot, 6 feet, 2 feet. Okay? Times the 2 feet that I have there. Okay? So, minus 25 kips feet plus 27.5 kips times 2 feet. Okay? Do the math out, and we should get a 30 kip feet. So far, so good? All I did was take the last moment at C, add the area of the next portion of the shear diagram to my moment. Tyler nodded his head.
What's the line? The line going across above the
This one?
yeah.
That's just 0. Yeah, we'll call that 0, just like this one up here is 0. Okay. So the horizontal line just is 0 where everything's hunky-dory. Okay. All right. So the line for this one then goes up to 30. And I know this isn't to scale. Well, actually, I can make it to scale. At 25, 30. Okay, like so. Everybody good? All right, the next one. Did I say moment at B? Oh, hold on. Thank you. Just thinking to myself, it's like C, B, no. All right, the moment at E now is the moment of D plus V of D. Yeah, V of D times 6 feet. Okay. And that becomes 30 kip feet plus, now my VD at that point is 2.5 kips, and that continues for 6 feet. Okay. And that leaves me with 45 kips. So we're now moving up to here. There, okay? And the last one is the moment at B. And that's the moment at E plus V at E times 2 feet. So 45 kips feet plus a minus 22.5 kips times 2 feet. And if all the world's in the right place, we come back to 0. Okay? And then literally just plot downward. Okay? So put a line out, didn't I? Jeez, erasing things and got slapped at me. All right. Any negative shear has a negative moment. Any positive shear has a positive effect for the moment. Okay? And then positive, we're still growing upward, and negative, we're going back down. Okay? Everybody straight, clear, simple? I don't know why I was trying to make life complicated. Other than I'm trying to emulate the book. Copy book. Okay. This will work. A little simpler, a little easier to see, more visual. Okay. The other way is you take the moments and you get all the stuff. And you can think of this as every time I'm doing one of these moment equations, I'm literally drawing this. Let's do let's do let's do A, that's C, and this will be D, okay? So I have a shear that's going on there, V at D. I have a reaction up here at that, and I have a force there, correct? Yep. And then what I have is, that's my moment, okay? And that's really all I'm trying to do with this thing, is anytime I'm taking that slice of the beam, is account for all the things that are causing the forces, okay? So the author wants you to go about it this way, okay? Well, my method basically says, I did A and C already. I know the moment of C, okay? So just plug it in. But I don't really know what's going on out here. That's what I'm solving. Okay? Make sense? And by the way, so if this is the point where I'm taking a moment about, the only forces that are actually out here are these two guys. Okay? So this force has that 2 feet. This force has that 1 foot. Which if you go back up here, negative 25 times 1 could be plugged into this part of the equation. And then the C times 2 feet, which is what I got right there. Okay? You do it either way you want, as long as you get back and everything solves to 0, the world's a happy place. Yes? Cool. Why spend so much time on trying to do that? Good? Carter, stress level is.
We solid.
We what?
So we're solid.
We're solid. That's not the word I would have thought of, but okay. All right. So, just to make life simpler, I even went and proved this out to myself over the weekend to see if I could come up with some stupid, crazy thing that actually works. So, let's try this one. Three, four, three. 3, 4, 3. Okay, so that's the beam. We're going to find the shear and bending moment diagrams. Okay. Justin, if you ever lose that penmanship, you're crazy.
Think so?
Yeah, I don't know how you perfected that over the years, but if you guys haven't seen his work, you should look at it. Or it's up to the world. You're fine. Don't have to erase it. It's just sudden. It's like, okay, everybody got it down? Look at Montana trying to get it. Oh, no, we're gonna work through it together. You're gonna do part of it, I'm not doing this one. perform in class exercise. Although it'd be a hell of a good one to give a quiz on, wouldn't it? Yes, but not after we just sorted out the moment stuff. All right, so first step is free body diagram, right? Actually, this is my free body diagram because I didn't have a beam to start with, or a picture out of the book. Okay, second step. So actually, if you want to do this, 1, 2, find reactions. Okay, easiest way to find reactions are, actually the only way to find reactions are,
The diagram.
no, that's getting into the next step. But just looking for RL and R sub R, it's the first thing you want to do. Okay, choose a direction. Okay, so we're going to do that. That's positive. But what's the... Okay. With me, everybody. There's some very simple things you have to do. And never forget them. First thing, sum of the forces in the Y and sum of the forces in the X. And if it's three-dimensional, sum of the forces in the Z. And then sum of moments. Okay? So, seeing that it's a two-dimensional beam and we only have vertical stuff, I'm going to do sum of forces in the X. Okay? But I want you to repeat with me. Sum of forces. Sum of moments. Sum of forces. Sum of moments. Sum of forces. Sum of moments. Don't forget it. You didn't say it. There's a sign that says. If you can remember that, okay, any beam problem you ever do from here on to the next design course or anything else in your life, you got someplace to start. Okay? Because all we're ever looking for is what are the forces? What are the reactions? Where are things happening? Okay? When we know that, we know a lot of things. Okay? So, say that to yourself every time you do one of these problems. Sum of forces, sum of moments. Okay? So, Eloge, I think you were shooting for this. Because you want me to pick a direction. Okay? So positive. They got to be equal to 0. Otherwise, the thing spins out of control and just goes off into space and never comes back. Okay? All right. So literally here, I'd be RL minus 7,500 minus 5,000 plus R sub R. Okay? Can I solve it? No. Why? Two unknowns, so I don't have enough information. Okay? So go use the next one, sum of the moments, and you get to choose your moment. So it doesn't really matter to me. The other thing that does really becomes important is which way is clockwise and which way is counterclockwise be positive. You got to choose one or the other so you're consistent. Okay? There's no flopping back and forth on the clock. Okay? Question. All right, so I'm going to choose counterclockwise, which in my world makes it a hell of a lot easier if I look at everything from A and work my way, my moments across. Okay? See why? Doesn't really matter. I could go from the other end, or I could go counterclockwise. As long as you keep the negative signs and the positives straight, the world's a good place. Okay. So you can choose whatever way you want. So I'm going to go the moment about A, and that'll be negative 75 pounds times 3 feet. Oh, you guys didn't know that. 3 feet, 4 feet, 3 feet. Minus 5,000 pounds times 7 feet. Okay. Plus R sub R times 10 feet. No, 7, 3, 10. Yeah, 10. Yeah, 10. Well, I was thinking 11. Okay. Now, R sub R has to come to this side. And I can bring the 10 with it if you want. Just I'll do it that way once. And when I get done, I should get £5,750. Yes? Cool. My stress meter over there says yes. All right, so that gives me this one. Now I can go back in and just plug those numbers into some of the forces in the Y and get my reaction. Or I could do another moment. Your choice. Okay? Doesn't really matter to me as long as you know you can do both. Okay? The dumbest thing I always thought when I was a student is like, yeah, so they told me to do sum of forces in the Y and then do the moment, but I can't solve sum of forces. So I got to go back and put another line in sum of forces again. I've always taught it this way, but if you're smart, recognize up in front, then you got to do a sum of moment first. Okay? Then you do sum of forces. Okay? But it is that, let's say this. Most people will associate forces first, moments second. Forces are just vertical or horizontal, whatever, or even at an angle, right? But the moment gets complicated because I got to know the distances. Okay? So I think that's the way it was always taught to me, and that's why I keep doing it that way. Doesn't mean you have to, though. Okay, so sum of moments, just make sure you label it. All right, we're going to go sum of the forces here. So we're looking for RL, minus 7,500 pounds, minus 5,000 pounds, plus 5750. Okay, and RL goes to the left side of the equation, and everything becomes, when we solve all this, it turns out to be 6,750 pounds. Okay? So far, so good? All right. Now for the fun. So there's V equal to 0, and we are in pounds. Okay? All right, so find the shear. And that would be step 3. And that's A, B, C, D, and it's 3 feet, 4 feet, 3 feet, just so you got the numbers again. Okay. All right. Who wants to come up and do the first one? Justin, you want to try it? Write the first equation. Well, so what's the reactions? So where's the forces? So when you're looking at this, you're looking for the first force you're going to come across. 6,750, right? Okay. So literally, V at A is equal to, actually, if you want to do this in letters, it's equal to RL, right? Which is equal to 6,750. Okay? So this puppy is going to go vertical. Yeah, that's close enough. Okay, so it's going straight up. Is there any other forces until I reach B that's going to affect that? So what's the shape of the line? Straight across, right? So I go straight over to B. Everybody see that? Okay. From there now, we're looking for V of B, okay? And we have a force there, 7,500, that's going to shove it down, right? Okay. So when you write this one, write VA plus force at B, okay? And VA is 6,750 pounds. Force at B was a negative 7,500 pounds. And by the way, that still goes with that's positive. Okay. And I'm going to wind up with a negative, oh, where'd it go? 750 pounds. Yes? So down to here. Okay. Henry, what's the next one? Yep, find V of C. Okay, again, positive's up. What's the equation going to be? VB plus the force at C. Okay. So VB was a negative 750 plus a negative 5,000, right? So that should be a negative 5,750. Okay? So we're going down to here. Okay? And that stays constant all the way across because there's no other forces acting on it between C and D. Correct? Fidel, you good? Okay. black, please. V of D
equal BC plus FD.
plus
FD.
R in this case, or the F at C or at D. Okay, so negative 570 pounds plus 5750 pounds, and it's 0. Okay, so this comes right back up to here. Okay, let's have a little chat about this for a second here. So if you are going along here, and you get to this last vertical line down here on the shear diagram, and you don't come out with the number here that's going to take you back to 0 there, you got problems. Okay? Don't even try to go past that. We'll figure it out. But if you get here, and you know that that's the answer to what the reaction is, cool, we're done. Okay? You don't have to really calculate the next thing. Doing BD, B sub D, is really about checking to make sure you're zeros. Okay? That's all you're doing. But usually by that third point, in this example, if you get to the end and you're just that last step, you can pretty much cheer yourself on, you're good. Okay? And there's that moment of excitement where I've solved the problem. Okay? Okay. Cool. All right, step 4. Find the bending moments. Okay? And go that way, positive. The moment at A should be 0 in this case because there's nothing hanging out there. Okay? No distance, no nothing. Okay? So we get I need a line. Bless you, yes. Let's do a line across there. So there's my moment, equal to 0, and that's pounds, feet. Okay? All right, so we start at 0. So our really next one is the moment at B is equal to VA times 3 feet. Yes? So think of it this way. There's my beam. There's RL, and that's my V at B, and there's my moment. Okay? So literally taking the moment at B here, all I really have is that reaction out there times that distance. Okay? So in essence, it's VA, that's the force, times 3 feet. So VA was 6750 pounds times 3 feet. And we should get something corny like 20,2025 or 20,250 pound feet. Yes? Okay. Good. Cool. Next one. So the next equation is the moments at C, ABC, yep, C. And that's going to be equal to the moment at B. Oh, by the way, I could have put the moment of A up in here too, and I should have, just to keep bookkeeping straight. The moment at B plus the V at B times 4 feet. Don't need that. Okay. And 20,250 pound-feet plus VB is negative 750 pounds times 4 feet. And what do we get for an answer?
Negative 3,000.
This plus that?
I got
17, yep.
I don't know. This is really wrong.
Okay. So that takes us, oh, I didn't draw the other one in. Shame on me. Let's see, Hughes green. So we're going up to here. And that's 2,250. And then we're going down to 17,250. We're good. All right. M at D is equal to MC plus the V at C. Didn't I write that down in there? I didn't write that down in there because I got all excited. 5750. Okay. Times 3 feet. Okay. And we should get 17,250 pound-feet plus a negative 5,750 pounds times 3 feet, and we're going to get a 0. Okay. So the last bit of this is that. Okay. Seeing how this works? Larger, Henry? Are you good? Frank, you good? Lois? Got it? Can do them on your own now? I can go home and I don't have to teach anymore? That's the greatest joy of every teacher. When I'm done teaching, you guys know how to do it, I don't have to do it anymore. Alright. Now, in 5 minutes, why do we do this? And why do I do the diagram? What do you think, Emma? Don't know. Said it about a week ago now. Time to bring it back into memory. So we're looking for the maximum moment, right? So we're going to try to find the stress in the beam. Okay. So in order to find the stress in the beam, we need where the max is. Okay. So most of the time, it's not just drawing these. What we're looking for is that point right there. Okay. Almost all the time, your max moment will occur where the shear diagram crosses the 0 axis. Okay. It can happen in other odd places once in a blue moon, but it's only because you got some real compound thing where there's a offset load on it, which creates another moment, and a bunch of other things like that. Okay, I'll show you a couple of those in this week sometime. But right now, the max moment is there. Okay, so what we're really looking for is step 5 would be Okay, and I didn't give you a seed, I didn't give you a shape, so we can't really go find that. But basically, that's where it gets plugged in. Make sense? Okay. Is there anyone at all confused, lost, frustrated? Want to throw up your notebook and start over again, go away? Anybody? Cool. If I start getting complicated in class again, because I'm trying to follow the author, throw the damn book down. Okay? This isn't hard. Okay? Tedious, confusing, but it really isn't hard. Okay? But I will tell you this. Okay? Just as if we're doing some of the moments, some of the forces, figure the statics portion of that stuff. Step one really, no, step two is. Step one is a 3-body diagram. Step 1 and 2 is statics. Okay? I don't care how you cut it, slice it, dice it, whatever. Okay? It's still statics. Steps 3, 4, and 5 is strength and materials. Okay? The design stuff that you're going to get into next class is really about factor safety and judging things against stresses and knowing whether the stresses are for soft ductile material or for cast iron or for other things. Okay, we use a whole bunch of parameters in designing things. Okay, that's not where you're at yet, but here's where you are on beams. Okay, I don't care who you think you are. Following steps apply. 1, 3-body diagram. 2, find reaction. Okay, the static. Some of forces and some of moments. 3, create the shear diagram. Okay, or the shear equation. You don't always have to do a diagram, but diagram helps visualize. 4, find the moments. Okay, find the maximum moment. Okay, you could have a couple maximums, not a couple max, but you can have a couple moments in here if you want to be suspicious of, okay? And the 5th one, find stress. Okay? Once you do that, I think I lost a finger in there. You get all 5 parts of that, you're golden. You can't screw up a design class. Can you? Yes, people do. Okay? Trust me, I did too. But once you get this down, this is like the icing on the cake. Okay? Actually, it's the cake, not the icing. The design is the icing. Okay? Just repeat this over and over again the rest of your life. I can't stress that enough. Okay? It doesn't mean that engineering is boring, but these are just the steps we go through to get to those numbers. Okay? All right. See you on Friday. And I guess Friday is probably a good time to have a little quiz. So practice this stuff. Just pick up some numbers, pick some problems out of the book. Try it. Actually, the ones I gave you, we didn't go over those, did we? Tell you what, for homework on Friday, hand them in, but try the bending moment diagrams for those 2 problems I gave you on last Friday.
It's like a homework quiz. Right?
Yep, homework quiz thing. Thanks, sir.
See you Friday.
I'll be here. Unless somebody creates some problem